Let me show you what perfect memory looks like for an agentic system. It remembers a decision you made 6 months ago and finds it even when you can't remember the exact words you use. It loads the right context automatically, so you never start from zero. And when it gives you an answer, it can tell you exactly where that answer came from. And even when it doesn't know, it says so instead of confidently making something up. Now imagine that scaling across a team of people using it. Now the problem today is that no single system does all of that really well. After digging through Hermes, GBrain, MemSearch, and a bunch of other memory architectures, I started to realize something. They each solve a different part of the problem. So instead of picking one, I pulled the best ideas from each and rebuilt them inside Claude Code. And honestly, it's better than any one system on its own. And more importantly, I understand every layer underneath it, which means I can swap pieces out, extend it when I need it, and keep it portable as things change. So in this video, I'll show you exactly how it works, the ideas I borrowed from each system and why, and how to copy the setup for yourself. So let's get straight into it. And firstly, I wanted to explain why not just use Claude Code out of the box, because Claude Code does already have a memory system and it does 3 jobs. So the 3 jobs are storage, injection, and recall. So storing a fact when you want it to and when you ask it to, injecting the right context when you open a session, and recalling something old when you ask about it. And for each of those, there's more than one way that you could actually do it. And I worked this out by going through around 20 different memory frameworks, and you can see parts of that in my previous videos. But the point is, the same variables kept coming up. So take storage, for example. You've got 2 separate decisions to make. Firstly, who triggers the save? Is it a hook firing automatically, or is it going to be the agent deciding what's worth keeping from what you told it? Secondly, what form does it save in? Is it going to be verbatim, so word for word, or summarized by an agent first, and which is better for your use case? So verbatim keeps everything, but it's bulky in terms of storage, and summarize is obviously more lean, but the agent decides what survives, so you might lose important context. Then separately, injection has its own variables, so you can either have a hook that loads the right files every single session, so it's guaranteed to push into the memory, or you can add that context to something that the agent decides to pull, like the Claude.md, and you're obviously waiting on a judgment call from that agent to decide that too. And underneath that also, do we have a cap on the number of characters that are injected? So a cap's going to keep the context not bloated, but we might lose some context with that cap. And then recall comes down to how you search. So keyword search finds exact words, but semantic search is going to help us actually find words by meaning. And then you've got hybrid, which does both. So those are the jobs and the choices you've got to make when picking out a memory framework for your use case. And here's what Claude Code actually picks for each of those. So for storage, it's agent decided and summarized. So the agent quietly noticed things worth keeping and writes a condensed version to the disk. And the problem with that is it's super selective. If the agent doesn't flag something, then it never gets saved at all. So the storage is okay for this, but it is a bit leaky. Now, injection, on the other hand, is going to load in the Claude.md by default and a memory index at every session start. So the memory index is a file that points to specific memory files that, again, an agent has decided to save over your conversation history in that repository. So it's loaded in using a hook, which means it always happens no matter what, but it's completely unbounded. There's no cap on characters, and therefore there's nothing keeping it lean. So the injection measures inside Claude Code out of the box are pretty basic. And then for recall, I'd say this is the worst of the 3 out the box. There's basically no search at all. So there's no keyword search, no semantic search. And if a fact wasn't saved as a memory in a memory file that's referenced by the memory.md index file, then it's completely gone. And your only fallback is to basically go and find the session that you're in and resume that session specifically to basically take the existing context of that conversation. So if that context has already been compressed, you might have even lost that context already. So storage is decent. The injection is pretty basic, and the recall is quite frankly quite weak. But when you zoom out holistically at why we need these, like all 3 of these, storage, injection, and recall, are required to improve the quality of your outputs. And that's why open source frameworks have focused so heavily on memory and injection of that context. So the plan is actually super simple. For each of these jobs, we keep the part of Claude Code that actually works, and we layer on add-ons to enhance it. So let's start with storage. So if you remember, Claude Code's storage choice was agent decided and then summarized. And the summarized part is actually fine. It's going to keep things clean in our memory storage. But the agent decided part is where it's arguably the weakest. So the fix is to keep the summarizing, but add an automatic hook. So nothing depends on the agent actually noticing and therefore deciding what to keep. And that's exactly why we've chosen MemSearch for this part of the framework. So after every single turn, a hook fires. It's going to summarize what says with a cheap, fast model like Haiku and appends it to a daily log. So it doesn't have an opinion about what matters. It's basically just going to capture all of the information and then turn it into a condensed format and store in a daily memory file. So why did we choose MemSearch for this and not the others? Well, Hermes also auto captures, but it actually captures the raw transcript, which is bulkier than we probably need, but it's just a preference at the end of the day. And GBrain 2 goes further again. It builds out a whole knowledge graph, pulling out people and companies and linking them, which sounds really clever, but it's probably a little bit overkill for just a business running a handful of clients. It's just too much. Whereas MemSearch hits the exact combination that we wanted. So it's automatic and it's summarized. So for storage, we're basically keeping Claude's auto memory and adding the MemSearch capture hook on top of it. Nice and simple. Now, how do we get that information that we stored back into every conversation, or the most important parts of it? But before we discuss that, if you're getting value from this video, do me a massive favor and hit the subscribe button below. It genuinely helps my channel. Claude Code's injection choice was hook loaded, so always in, but not capped at character count. So Hermes handles this in a really smart way. So at the session start, it actually takes a frozen snapshot of pertinent and specific memory files. So think your identity, your user profile, and your most important recent memories that it's saved into the memory. So it's going to be capped around 1,300 tokens, so it's not going to bloat the context, and it's cached. So you're only going to pay for these tokens once per session. It's not going to re-inject them into every bit of conversation. So why then did we choose Hermes for injection and not MemSearch? Because MemSearch actually, believe it or not, doesn't have an injection layer at all. It's just a storage and search library. So it stores it really well, but it never decides on how that memory reaches the agent. So we have to employ something like Hermes to make sure that actually a snapshot is taken and then injected into the context for great short-term recall. Now, we took the frozen snapshot from Hermes, but actually we didn't take the rest of Hermes because its recall is keyword only. Now, just to remind you, Claude Code's recall choice was no search at all. So you'd had to go back and resume the specific session. So this is the biggest upgrade to the system around memory. And it's where two frameworks are actually combined. This is where we can add the most value in terms of Claude Code out the box. So the base comes from MemSearch. So everything we stored at the start in the storage stage gets indexed as vectors on your machine. And because it's on your machine, there's zero API cost. And then the search is completely hybrid. So we're able to do semantic search by meaning and also by keywords. But the way that this works is actually a multi-tier system. So what it's going to do is check the injected memory first. So it's not going to go and search deeper. If we have the information already in that frozen snapshot, it will stop at tier 0. But if it needs to recall information at a deeper level, it will basically go through a 3-tier system, delving deeper until eventually it does this hybrid keyword and semantic search to pull back all the full context that's been summarized by MemSearch in the first place. So again, why do we choose MemSearch over Hermes for recall? Well, this is actually the flip side of the injection choice. So Hermes recall is keyword only, but MemSearch allows us to actually layer on top that semantic or by meaning research. So it's going to find your conversation no matter which word you use, which is really important if you're handling multiple clients or lots of different projects. Now, why did we actually combine that with some of the elements of GBrain? We combined it because basically MemSearch returns you chunks back. So it's like 10 bits of text that potentially match what you've asked it for, but you still have to read them and work out the answer, or the agent does. So we've basically taken an element from GBrain, and this is a framework that Gary Tan from Y Combinator built, and it basically does two things on top of this same hybrid search. First, it's going to use a re-ranker, which does a second pass over all of the collected chunks and reorder the matches, so the best ones are more likely to come first. And secondly, and this is the one I actually care about, it doesn't return chunks, it returns a written answer with citations. So it's not just throwing back a bunch of information that may be relevant, it's actually going to return that written answer with a bunch of citations where it's taking that information from. So most importantly, that's going to tell you which file or conversation it came from, and if the information isn't there, it's actually going to tell you it isn't there. And remember at the start when I said a good memory system should admit what it doesn't know? Well, that is exactly this. So a confident answer with no source is actually worse than useless when you're running real work for a client. So for our recall tactic then, we've decided to combine both. MemSearch for that hybrid search that finds by meaning, and then the GBrain approach on top for the re-ranking and that really well-cited sourced answer. So when you pull everything together then, it looks a little bit like this when you consider storage, injection, and recall. So it's a combination of the best practices of multiple frameworks loaded into a custom-built framework. But you understand exactly what's under the hood because you've cherry-picked the best parts of both. You've decided which parts to use based on the variables that you can choose from, and you're storing everything, injecting just what matters, and able to recall semantically by meaning with the sources too. So everything you've seen so far, we've already built into our agentic operating system, and it comes shipped out of the box. So you get going from day one with a one-line install. If you want that, it's down in the description below. So there's something critical that we haven't mentioned yet that we're building into our framework in June. And it relies on the fact that mostly you want to use memory like you do with shared folders. You often work collaboratively with others. So you need other team members to access certain parts of your memory and then the other parts to be completely private to you personally or to each individual user that's got it installed on their machine. Now, because we've built everything as these separate blocks that plug and play together and not one locked framework, the same setup can be used to effectively scale to a whole team. But building it for a team is where things do get harder. So memory has to be shared where it should be and private where it shouldn't. So it's split across clients, departments, projects, etc. And the GBrain was actually the inspiration for the architecture behind this. It solves it with what Gary Tang calls a company brain. So one central store, but each person gets their own individual slice scoped by their login access token. So person A, for example, can only access the clients they're actually meant to access. Person B might have more access, and this is all scoped by row level security and the token that we give to that individual user. There are effectively two ways to do this, and I covered the full team setup in a separate video that I'll link at the end. But here's the short version. The simple way, which is going to suit some teams, is one memory index, one database per person. So it's built only from the files they're allowed to sync. So person A builds a memory file from the client files that they're allowed to access. Person B, the same. Person C, the same. But this comes at the expense of actually then you don't have a shared brain at all. You just have isolated memories between these individuals. And that's what we've described throughout this video. And then the scalable way is one shared store, something like a Postgres database held on Supabase, for example, with row level security. So every memory row is tagged by client or by project or by department. And every query then is filtered by who's asking. So every query person A makes, we're able to restrict access in that memory. So only those permitted actually get access. So this, as you can imagine, is significantly harder to set up, but you get one shared brain across the whole team. And that's the one that we're implementing personally. And I'd highly recommend if you work across multiple users to do that too. So quick recap, I pulled the best ideas from each memory framework and rebuilt them inside Claude Code. Now, why did I do that? Because no single framework had a comprehensive answer to the three jobs of storage, injection, and recall. So we've just taken the best of each framework and pulled it into one comprehensive system that's plug and play. You can use it with Claude Code, Codex, and any other harness. So next video, I'm walking you through the full team operating system that this memory system plugs into. And if you want to just get this all out the box with setup tutorials, then check out the Academy link in the description below. See you in the next one.